All right. This is what we did in class today. This is before the reaction with methane gas plus oxygen gas. Notice we converted grams to moles, no big deal. And then notice we can add the total moles in to PV equals nRT. Of course, we're solving for P there. And then we times by R, constant, 0.0821, liter atmospheres moles Kelvin, to times by the Kelvin temperature and divide by the volume, and we can get the total pressure. So let me mark here total pressure. That's important. Notice there's our volume and there's our temperature in Kelvin for the initial start of this question. So that's before the reaction. Let's spark this, and we're going to get a combustion reaction. And we're going to produce carbon dioxide, water, lots of heat as well. But let's consider the stoichiometry. We have a 1 to 2 to 1 to 2 stoichiometric ratio. We figure out limiting and excess. Notice the methane gas is limiting, so that determines product. So notice this determines product, and then we'll get the exact same amount of carbon dioxide based on the stoichiometric ratio of 1 to 1. And then, of course, it doubles product there for water based on the stoichiometric ratios. Here's our total amount in moles of oxygen gas. Notice 0.25 moles is used, that is moles there. And how do I know that 0.25 moles are used? I can calculate that. I know, and in fact, I don't even need a calculation because I know that this reacts in a 1 to 2 ratio. So notice 1 to 2 ratio, so we're going to double that amount for used. And there's my excess. Of course, excess plus used gets you the total that you start with. After the reaction proceeds to completion, all of that is used. This is used, and we're left with these gases after the reaction. That's the moles of gas present after the reaction has occurred. Here's where we started. Spark, kaboom, chemical reaction. Here are the gases that are produced as a consequence of that chemical reaction. Notice we have a little bit of oxygen gas left over, and we've got product there. Interesting, the total number of moles here, if you add these, is identical to the total number of moles here. Notice, why is that? Because this balanced equation tells us that 1 mole of CH4 plus 2 moles, there are 3 total moles on the left side, and there's 3 total moles on the right. We have not gained number of moles or lost number of moles in this reaction. If we haven't gained or lost moles going from the left side to the right side, and notice volume is the same for both, before and after, temperature hasn't changed, number of moles of gas hasn't changed, so the total pressure as calculated over here would, of course, equal the total pressure here. One more time, P equals nRT over V. Total pressure, this quantity, has not changed as we just saw. R, of course, is not changing. The temperature hasn't changed from beginning before the reaction to after the reaction. The volume hasn't changed, so obviously the total pressure would equal. So this will equal that. So they would equal each other. If we have a different reaction with different stoichiometric ratio, again, we'll use this one. Notice 3 moles plus 1 mole yields 2 moles of ammonia. Now, no matter what molar quantities we start with in whatever ratio, once you figure out limiting and excess and go through the process, you will always have less number of moles on the product side. And if you have less number of moles, according to P equals nRT over V, if the number of moles goes down, which it does, 4 moles versus 2 moles, then the pressure, total pressure, would have to go down. Look at that relationship. That change in number of moles is based on the stoichiometry of the balanced equation. Be careful. We know for this to hold true, the volume would have had to have been constant. So that hasn't changed. Before the reaction and after the reaction, it was a rigid container. Notice also, this is assuming the Kelvin temperature has not changed from before the reaction to when after the reaction occurs. So that means the only thing that is changing is number of moles, and again, number of moles are going down, so total pressure is going down. I hope this is helpful in your understanding.